Good morning, everyone. Look around you today, and it is almost impossible to imagine modern life without aluminium. From the high-strength fuselages powering global aerospace to the hulls of high-speed marine vessels, its strength-to-weight ratio is legendary. But perhaps its most impactful role is right where we stand, in the construction industry. Aluminium is the backbone of modern building envelopes, forming the windows, doors, and complex facade systems that define our urban skylines. Today, we are going to look past the finished facade and explore the raw physics, metallurgy, and critical sustainability life cycle of this extraordinary metal.
To understand aluminium, we have to start at the Earth's surface. Pure aluminium doesn't naturally exist on its own. Instead, it is extracted from various ores, primarily bauxite. High-grade bauxite contains roughly 55% aluminium oxide, making it the primary starting point for manufacturing. However, this presents our first major ecological hurdle. The world's largest bauxite deposits lie right along the equator, sitting directly beneath our planet's most vital primeval rainforests. Because bauxite rests near the surface, it requires extensive surface mining, meaning these crucial forest ecosystems must be cleared to reach the ore. Once mined, refining primary aluminum requires a two-step chemical and electrical process established back in the 1880s, the Bayer process. In step 1, raw bauxite is treated with caustic soda and thermal energy to extract a fine white powder called aluminum oxide. This step leaves behind a highly alkaline, toxic waste byproduct known as red mud, which poses severe disposal and environmental risks. Step 2 takes that white oxide powder and subjects it to industrial electrolysis. Using carbon anodes and massive amounts of electrical energy, the oxide is finally reduced into primary liquid aluminum. In today's economy, this extreme electrical demand makes primary aluminum incredibly expensive to produce and heavily carbon intensive. Now here is a surprising metallurgical fact. Freshly smelted primary aluminum is actually too soft and flexible for building construction. It lacks the structural rigidity and weather resistance needed to withstand intense wind loads or resist corrosion over decades. To fix this, the metal must be alloyed. By precisely blending elements like magnesium and silicon into the molten metal, we radically transform its mechanical properties. In the architectural world, the gold standard alloy is designated as EN-AW6060. The EN denotes European standard, W stands for a wrought product, and 6060 signifies the specific construction-grade recipe optimized for structural integrity and pristine surface finishing. So, how do we transform this structural alloy into actual building components? Unlike steel, which is frequently cast or rolled, construction aluminium is formed using the extrusion process. Think of it exactly like a commercial pasta maker pressing dough through a shaped mold. In a heavy industrial press, a solid billet of our alloy is heated until malleable, then forced under immense hydraulic pressure through a high-strength steel die. Out emerges a continuous, perfectly formed geometric profile, such as a hollow window frame or a curtain wall mullion. This incredibly efficient process allows us to design complex, lightweight shapes with practically zero material waste. Everything we have discussed so far brings us to the most vital part of the conversation, the Secondary Aluminium Revolution. Secondary aluminum is simply metal produced by recycling existing aluminum scrap. Aluminum possesses a miraculous superpower. It can be recycled infinitely with absolutely zero loss in material quality or structural performance. By shifting to secondary aluminum, we completely eliminate the three major problems of primary production. There's no surface mining, no toxic red mud,
And most importantly, it requires 95% less energy to manufacture than primary metal. We only need a mere 5% of the power to melt down and reuse this material, making a closed-loop cycle an absolute necessity for sustainable architecture.
To wrap up, aluminium is fundamentally a 100% recyclable, circular material, perfectly suited for the future of green building design. While primary extraction carries massive environmental and energy costs, the structural agility of the extrusion process, combined with a 95% energy saving in recycling, makes it an elite asset for high-performance architecture. By committing to strict material recycling frameworks, the construction industry can continue to build inspiring, resilient, and truly low-carbon urban environments. Thank you, and hit subscribe. I would be happy to open the floor to any questions.